Okay, so welcome class and good day. We're going to have now an illustration of framing system modeling, wherein we are going to have another method in delegating the floor loads. So last time we have done it by a grouping, a group of members, and then delegate the loading. But the problem on that method is that we cannot delineate the areas where we have an open flooring or open below flooring. So let's start. So as usual, we are going to have a file and then new. From that we have space, then we rename certain file here. We have exercise, say exercise 08 2021. Okay, so we just tick next and we start with add beam. Finish. So of course, first things first, we are going to establish the structural elements. So actually we can do it by nodes method or snap node beam method, this one, and then by coordinate method, and then by direct importation, and the last one is the structure wizard. So I'll just have a model by node method na lang. So first you are going to have a view from Y. Say I'm gonna set my first point as 0 0, and then we use this translational repeat. Okay. Steps along X, say we have 4 spans of say 5 meters, and then we'll just have to click link steps. Okay, and then from this we can also repeat it on the Z axis. Along the Z axis, we select that one, and then Z tayo, and then the steps, so we have 4 with default spacing of, let's say 4 meters. Okay, say this is our model. So anyway, this is just for demonstration. So now I'm going to translate it on the vertical. Say this again, the vertical Y. Say we have a 3-story building. Remember, the 4th level will be our roof. Okay, so we have link steps, then we just tick OK, and of course we will now have this model. So we delete the lower beams. Okay, say we have this type of typical framing system. Next, after your geometry model, of course we'll just follow this sequence of workflow, no? So from the geometry we will go now to the general. So this time we are going to have the properties in it. Say we are on the reinforced concrete model. For our columns, we set it as a rectangular one. Say I'm going to have 0.4 by 0.4 meters. So we add that one for a while, and then another member for the beam. So I'll just have a uniform beam of size. Of course, the minimum size in the code is 0.25 for structural moment resisting frame. Okay, seismic resistant framing system should be having a minimum dimension of the structural element of 0.25. Okay, and then I'll just set my depth to say 375 or 0.375. Then I'll just have to add this one, and then all we have to do is to assign all of this. Okay, so we can now take advantage of the tools tab here, and then the selection. We now go to the selection, tools. So every time the software will ask you to save, just save that one, and then beams parallel to Y, so that all of the vertical members will be selected here. Okay, so select beams parallel to Y. Okay, so we just assign to selected beams, assign, and then for the horizontal members we can just select or drag a certain window here. Okay, of course initially you select horizontal member, then the other members, horizontal members, for the other horizontal members we hold the control button, hold natin yung control button, so that hindi man-select yung una mong sinelect. So with that we assign this. Okay, so we check our structure. Okay, so this will be now our structure. By this 3D rendered view, you can see all of the beams without property assignment. Okay, so in this case all of the beams will have its property assignment, and it is noticed here, of course, that we have nosing on each beam, so we need to apply here specs. Okay, so for this specs we are going to click beam, and then all of the horizontal beams will be offset downwards by half of the depth. So half of the depth is 0.375 divided by 2, that is 0.1875. So beam tayo dito. Then we just take this offset now. So by Y we have 0.1875 as our offset for the start. Then we assign that one. Then we click again beam. Then offset. This time we select end for the end beam. And then 0.1875 here. Then assign. So we check our structure. So of course, as we can see here, we need to indicate a negative sign here, so that it is an offset that is on the negative axis. So just edit that one, change, and then that's it. You can see here that your beams are already in place, and we do not have any offset or nosing on our structural model. Okay, so of course we continue working with this arrangement of tabbings. So from specs, we now proceed to support. So when we tick on support, we create support. Say we have here a pin connection. So we just select the nodes we need, and of course, the initial one is to add first your support. So anytime you can delete this and then create a new type of support. So in this case, we have a pin connection. So we have to select all the nodes on the bottom. So we just pick this assign to selected nodes and assign. So yes, we have here now the assign supports. So right after that, we now proceed to the loadings. So here we need to define our seismic or the earthquake parameters. So from the earthquake parameters, of course, we select the UBC 1997 or the latest. So of course, importance factor will be coming from our NSCP. So actually we have a guide here. Say we select an importance factor for a standard occupancy structure. So we just have a 1 factor. On that case, say number 4. So we just select this 1, and then for the seismic zone, so we only have two types of zone here. We have 2 and 4. So in our map, zone map, we have of course we belong to zone 4. So zone 4, we have 0.4 factor for that zone. So we have 0.4, and then for the RX and RW, we consider SRMF or special reinforced concrete moment frames. So that would have a value of 8.5. So for our basic R factor, or what we call the response modification factor. So the response modification factor will be equal to 8.5 in both X and Z direction. So 8.5, and then the soil profile type. So I'll just select a stiff soil profile. So this is a stiff soil profile with the following average soil properties. Okay. First, you can determine this by a proper soil investigation on your site location. So the near source factors, depending on the table again from the NSCP. So we refer to table on coefficients, the near source factors. So our reference will be 208-5, 2H-6, up to 208-8. So NA, the near source factor NA. Say I'm going to consider a distance of greater than or equal to 10 kilometers. Say the seismic source type is B. So all of the factors here will yield to 1.0. So NA and NV. Just place here factors 1, and then of course this is a constant equal to 0.0731, and then for the period, it is in the form of the formula here. I'm using here the spreadsheet to calculate that one. So this is the formula, or the CT, the constant CT multiplied by Hn raised to 3/4. We can see here the formula from section 208.5.2.2 structure period, and this is what we have used: 0.0731 RC concrete MRF, or moment resisting frame, and eccentrically braced frames. Okay, so Hn is the height of the structure. We'll just have to raise that to 3/4. See, we add this for a while, so we check the height. So the height is we have 5 meters each floor. So again, we go back to this. Say just edit this one of the spreadsheet. So we have 4 story, or 4 floors, 4 levels, I should say. Then that is 5 meters per level. So basically we will be having a height of 20 meters. So we just place that in here, and then we can see that the factor is 0.69, okay, or the T structure period, T is equal to 0.69. Okay, we go back to this, just double click that one, then we place the value here, then change, okay, close, and then from this we need to add cases, load cases under that definition. So we add here, first, number 1 is the self weight, and then say we have no joint weights here, and then the member weight, say we're gonna have member weights for the weight of our partitions. Say we're gonna set a value here. So let us have a spreadsheet to do that. Say we have this criteria from the National Code, Structural Code of the Philippines. We have this weight, and then of course we just have to have our height equal to 5 minus 0.375. So with that, the uniform load is 13.78. Say we have 13.78. So remember, in seismic definition, cases of load do not need to indicate negative sign. Okay, so just place a positive values here, unlike on the load cases details later on. So we just simply add this one for the member weight. If you notice, we have here a red question mark indicating that this case load or load case is not yet delegated to any member. Okay, so anyway, we'll go back to that one. So next is the floor weight. Okay, so for the floor weight, This time I'm going to introduce to you the use of range. Unlike before, that we have used the group scheme to determine the floor weight. Okay, so in here we need to work on the coordinates of the structure. Say we get first the section, so we get the coordinates, so of course, first things first, we isolate this. Okay, say view selected objects only, and then we go to the ground floor. So we choose the select node cursor, so to determine our range of values. So the first range, if we need to enclose, say I'm going to enclose this one, this rectangle here. So what you do is you define the range of x and z axis. So if we need to have this one, itong coordinate na to is 0 and 5, or 0, 0 and sa x and z axis 0, 0. So yung range ng z is 0 to 5, or 0 to 4 I should say. So the range of z is 0 to 4, and then the range of x is 0 to, this is 0 for x, and this is 5. Okay, and then the range of y is 5. Okay, remember, ito na yung top level, so that is the top level. So basically, ano bang thickness dapat ng ating slab? So of course, the thickness of the slab is equal to the perimeter times 2 divided by 180. Okay, so 100. So we have a thickness of 100 mm, a minimum thickness of 100 mm for every slab here. Okay, so therefore yung y mo mababawasan ng range yan. So the range shall begin on the bottom fiber of your slab up to the top level of your fiber of the slab. So let's do it. Say i-enclose ko to ng I'm going to enclose this for demo, no? Okay, so just add here, then floor weight. Say yung floor weight natin is again 100 mm times 23.5, or 23.5 times 0.1, that is 2.35. For this is the dead load of your slab. By the way, you do not need to define, you just need to define all of the self weight that are permanently attached to your structure. So yun lang ilalagay mo sa seismic definition. So you do not need to place the live load on your seismic definition, but only those dead loads or dead weights that are permanently attached in your structure. So yung slab is one of those. So I'll just have to place here 2.35. Now, define y range. So, your y range, the minimum starts dun sa level ng bottom fiber of your slab. So, what you do is, ano bang height ng floor to floor? So, the height of the floor to floor is 5 meters. So, from that 5 meter distance, we deduct 0.1. Okay, so your range now should be 4.9, no? Nag-minus ako ng 0.1 dyan. And then, the maximum range is 5. Okay, so meaning, there is a Y range of 100 mm. Okay? And then, for the X range, we have determined that from minimum to maximum of 0, kasi 0, 0 tong coordinate nito, hanggang dito sa 5. Okay? Up to 5. Okay? 0 hanggang 5. And then, for the Z range is Z range. Where's Z? This one. So, it is ranging from 0 to 4. So, this ranges from 0 to 4. So, if I'm going to add that one, we have that floor weight. Okay? So, later on, we will view it sooner on your load case details if we're going to place these loadings. Okay? So, for faster demonstration, for a quick demonstration, I'll just make it a uniform that all of our perimeter will be having a partition, no? So lahat ng ating perimeter shall have partition. So I'll just select all of my partition here. Of course, in most cases, you need to isolate every floor in order to establish the beams with partition. So upon selection of that one, we select that, then we assign to selected beams, then assign. So nawala na yung red question mark indicating that this item was already designated to these members. Okay. So in your floor weight, you have already defined as one range on the ground floor. So kung gusto mo, we will cover all of this, no? Anyway, itong ground floor kasi it doesn't have an open space in it. Okay? Unless may basement ka pa dito sa baba. So again, we select all of the floor by the selection, and then we select or view selected objects only. So kung gusto mo, i-define mo lahat yan, i-enclose mo lahat to. So the range will be again dependent on the node. So dito 0, 0 tayo, 0x and z, the y is 5. Okay, so okay naman tong y range natin. Ang magbabago lang is yung range ng x hanggang ano yan, hanggang 20. So x range is from 0 to 20, and then the z range will have 0 to 16. Yeah, 0 to 16. So we just change that one, then close. So we now proceed to the other floors. Say view selected objects only. So we have that one. Again, we have the floor weight. So halimbawa, we have this span as open, no? Sabihin natin open yung range na yan. So what you do is to kunin mo tong range na to, this one, itong rectangle na yan, okay, and then this one, and then that one, okay. So ganun lang naman yun. So of course we need the value of the coordinates again. Kung kukunin natin to, the range of x is 0 to 0 to this point, 0 to 10, no? So the range is 0 to 10 sa x, sa z naman 0 to 16, okay, 0 to 10 and then 0 to 16 for x and z. So again, we take this floor weight and then add, say 2.35 yan. The y range is ganun din, no? 4.9 to 5 meters. And then x range is 0 to 10, and z range is 0 to 16. So kung meron yan, we just add that one, then just close it. So we are done with this portion. So our next is this one. So of course we need to define the value of range x. So yung range x starts with 10 and ends with 20. So 10 to 20 yung x. Yung z naman 0 to 4. 0 to 4 and 10 to 20 for x. So x range is 10 to 20. And then z range is 0 to 4. And then y range is the same, 4.9. By the way, hindi na pala to 4.9, no? So kasi 10 na to, we are on the second level already. So 10 yan. So therefore 10 minus 0.1 is equal to 9.9. So ito we have 2.35. So we just add to it. Palitan lang natin yung iba dito, no? So this is 10. It's 9.9. Change. So we are done with this portion as well as this. So ito naman, no? So this rectangle here. Say this rectangle here, no? Okay. So that rectangle, so we have a starting point here. So this is the node. Starting point of x is 15. 15 to 20 yan. So this is 20. 15 to 20 yung x, and then z is 4 to 16. 4 to 16. So 15x to 20. Okay. And 4 to 16 for z. So again, I'm going to add another item here. So this is 2.35. The y range is 9.9, and then this is 10 yan, and then x range is 15 to 20, and this is 4 to 16. 4 to 16, and then add, then close. So tapos na tayo doon dito sa portion nito. Okay. And then finally we have this rectangle. So similar steps, same steps. We get the first range of x. So first range of x is 10. That is up to 15. So 10 to 15. For z, 8 to 16. So add 2.35. Then the y range is 9.9. 10 here for the second level. Define range. So x range is what's that again? We have 10 to 15, ano? 10 to 15 yan. 10 to 15. And then the z range is 8 to 16. 8 to 16. Then we just add. Okay, so I think we are already done with the second floor, no? We're already done with the second floor. So that's the steps in defining floor weight using the range. Okay, so we have already the range here. What else? So of course we apply the same procedure for the third floor level, ano? First floor, second floor. We apply the same to the third floor. So of course, ito magkakaroon ka ng the same set of ranges. Sabihin na natin open din yung ano mo. So yung titignan mo, we'll just have to take note of the ranges here. Okay. So we add another one here. Add. So the same 2.35. Ang magbabago lang is yung range mo sa y. So it now becomes 14.9. At yun is 15. And then for the x range, for the third floor, we will be having a 0 to 20 yan. Parang kinokopya ko lang to, no? So x range 0 to 20, and then 0 to 16 yung z range mo. So that is the first. And then we have the same y range. Okay, 14.915. So ito na yung pangalawa. So the X range is 0 to 10. Ayun, parang nagkamali tayo dito. So I think ito yung pangalawa dapat. 0 to 10. 0 to 10, and then we have Z range of 0 to 16. 0 to 10 and 0. 0 to 10, and then zero to 10, 0 to 16. So change that one. Then we add another one. Add. See, this is 2.35. Range is 14.9. Maximum is 15. Tapos X range, ito na. X range is 10 to 20 for then zero to 4. Okay. So we add 2.35 pa rin yun. Y range is 14.9. This is 0.9. Then 15 yan. So sa X range, we are already done with the 0 to 10 and then 0 to 16. So we have X range of 10 to 20, 0 to 4. 10 to 20, 0 to 4. Then we add. So the same naman yung Y dito. Then actually that will be the fourth item here. We have 15 to 20 X and then 4 to 16. 15 to 20. Then 4 to 16 for the X range. So we just again add that one. Then finally ito naman add 2.35. Y range is 14.9. This is 15. So X range is 10 to 15, 8 to 16. 10 to 15, and this is 8 to 16. So we add those. So this will be our floor weight. So we now proceed to the case details. So for the case details, of course, as usual, this is EQX. Then we set this as a seismic along X. Add. Then EQZ, another seismic for that direction. Say this is the dead load. So we select the dead loading type, add, and then the live load. Then we select the live loading type, so reducible by UBC or IBC. So here ito add. So from each of these load cases detail folder, we add the specific load items. So seismic loads. So along X, this is -1. So we check -1 here or consider accidental load. So add lang yan. We do the same for Z. but this time we just select Z direction, so -1. -1. Then consider accidental torsion load. Add. And then we proceed to the dead load. So we select the folder, then we add the item self-weight. So Y factor of -1, so okay. Okay. So we also need to place on the details or the load cases details all what we have defined here in the seismic definition. So we start with the member load. So the member load is 13.78. So we indicate now here a negative sign for that purpose. So we have negative 13.78 kilonewton per meter as uniform distributed load. We add that for a while. So again, you can notice that we have here a red question mark indicating that this is not yet designated. So sa floor load, lahat ng floor na dinefine mo dito should be also present in the load cases details, particularly on the dead load. Okay. So for the first floor load, this time we indicate all of the load cases items with negative kasi pababa yan. Then we check global Y, and then ito muna isa-isayin natin. So the range of Y is 4.9 to 5 with an X range of 0 to 20 at ito 0 to 16. So we add that one. Okay. And then another one, ito magiging 9.9. Then this is 10. So the X range is 0 to 10 with the Y range or Z range of 0 to 16. Z range is 0 to 16. Then we just place add here. And then the third one, we have the same Y range, and then X range is 10 to 20, tapos Z range 0 to 4. 10 to 20, Z range is 0 to 4, so we just add that one. And then for the fourth, meron tayong parehas 9.9 to 10 for the Z range, and then for X range is 15 to 20, 4 to 16, 15 to 20, 4 to 16. Okay, so we add that again. Tapos we have the fifth loading, the same din yung Y natin, 9.9 to 10. X range is 10 to 15, 8 to 16. 10 to 15, this is 8 to 16, we again add that one. What else? We go now to the 6 loading. Say x range is 0 to 10. Ito magiging ano na, 14.9 na siya. 14.9 at ito 15. So the x range 0 to 10, 0 to 16, 0 to 10, then 0 to 16, so we simply add that one. So pares lang, 14.9 to 15. Oh no. Add negative 2.35. So right y range. Oh wait. So I think dito yata tayo mag-define. Add floor load y range. We have here negative 2.35. And then 14.9 to 15. Tapos x range. Ano yung x range natin dito? 10 to 20, 0 to 4. 10 to 20. This is 0 to 4. Then we add that one. And then we have this 15 to 20, 4 to 16. 15 to 20 is 4 to 16. So we add. Then the last 10 to 15, 8 to 16. 10 to 15, 8 to 16. So we just add that one, then plus. Okay, so we have this completed loading here. So if we are going to click yung mga definition dito, makikita natin. The ranges were already generated on the floor loads, no? So mag-sample tayo dito, view selected objects only. Okay. So itong ground floor walang butas as we have defined, ano? So looking at the other floors, so say view selected objects only, ito may butas dito as we have defined, ano? Okay, so for the second floor, and then we proceed to the third floor, no? View selected objects only, ganun din, may butas dyan. So we have assumed that this portion is an open or stairwell, no? An open below flooring. So walang flooring dyan. So anyway, that's the purpose of having a range. Okay, using range. Unlike yung ginawa natin before, that we have grouping, we cannot really delineate the flooring with the opening, no? Okay, so we have a conservative approach on that one, wherein all of the flooring are having slab or covering. Okay, so Kulang pa dito itong definition of our dead load for this partition, ano? So of course this was already defined, kaya nga defined in your seismic definition, no? So hindi ka pwedeng magkamali, dapat parehas lang yan. So what you do is to tick this one, yung na-define kanina, and then dito nandiyan naman yung mga member, so we just tick this one, assign to edit list, and then from that we drag and select all of the items here, then right click that one, then copy. So balik ka dun sa item ng dead load, then assign to edit list, then we right click that one and paste, then assign. Okay, so kung nakikita nyo, naka-assign nyo talaga. So looking at the whole structure, what you have assigned a while ago will reflect, kasi nga kinopya mo lang yung members nito. So that's it. Okay, so for the live load, we will define the live load, the flooring, again with the following ranges. Okay, so again we add, then floor load, select the floor load item. So the pressure, say lahat ng ating live load is 2.0, no? For a quick presentation, I'll just have to adapt the whole flooring, no? So anyway, sige, let us have patience in doing it. Y range, we just copy this. Y range of 4.925, and then 0 to 20, 0 to 16, right? So we add, and then the next range is 9.9 to 10, and then 0 to 10, 0 to 16, 0 to 10, 0 to 16, so we add. So another one, we have 10 to 20, 10 to 20, then 0 to 4, so we add. Then 15 to 20, 4 to 16, 15 to 20, 4 to 16, so we add. And then last for 9.9 to 10 Y range, 10 to 15, 8 to 16, 10 to 15, 8 to 16, so we add. So magbabago na yung ating range of Y, 14.9 yan, tapos just save it, 14.9 tapos 15. Okay, 14.9, 15, X range 0 to 10, 0 to 16, so we add. And then 10 to 20, 0 to 4, 10 to 20, 0 to 4, add. Tapos 15 to 20, 4 to 16, add. Finally 10 to 15, 8 to 16. So we add. Okay. So ganun din, no? Okay, so we have those loadings. Okay. So that's it for session. And I think the next step here is the load cases details. So let us have the load cases details. So we add here a load case, define load combinations. So ang load combination for earthquake, so we can see here in our reference. Kung may earthquake, 1.2 yung dead load, tapos 1 na yung live, tsaka yung earthquake. So yung dead load dito, 1.2. And then yung EQX, 1 lang yan, tsaka yung live load. So we add that one for a while. And then dead load, 1.2 pa rin yan. So EQZ is 1 and the live load is 1. We add, and then finally, yung basic combination ng dead load, live load. Ito, 1.2. And then this is 1.6. We add, then close. Okay, so the next step will be, of course, the material. Select that one, and then concrete. We assign to selected beams. Okay, and then next, analysis or print. So we have no print. So we add that one. Then define commands. No print pa rin. Preprint. Define commands. Problem stat. Add. And then post print. Define commands. We just select all of the possible combination here. Then add. Close. So we are now going to the design. So define parameters. So notice naka-select pa rin yan, no? So if not, you tend to select all of the members. So what do we need here? Yung mga concrete cover. Ito yata yung sa steel design. So design, and then concrete. Define parameters. So we select this one, assign, and then FC prime. So we define the FC prime, say meron tayong 20.7 kilopascal or megapascal. So we assign. So the main reinforcement, ito grade 60 yan, so assign. So yung ating is grade 40, say 276,000. Then assign. So main reinforcement could be defined here, say 20, assign. Minimum main, say 20, assign. And then track, we can select the maximum details, assign. Then commands, design beam, huwag mo munang i-assign kasi nakaselect lahat. So add, design column, add, then take off, assign, close. So we go back to select all of the beams, all of the members. Yeah, select that one. We hold control dito, no? Then assign. So the design column, we hold control again. Okay. So from right to left ang pag-drag, Okay, so we check by isometric view, na select lahat, and then assign. Okay. So we are now ready to have our run of analysis. So analyze, run analysis, save. Okay. So in here you have now your design, okay, as well as from the post processing we have already explored this one. So we have to select the envelope and then graphs. For the envelope, ito yung kailangan mo. So this is the data you need for the design. If you choose to use another program, kung gusto mo, kunin mo lang yung mga moment values dito and then design it. Kasi ito may mga stress reversals dito. Okay? So, complete design ng STAAD is for reference only. Okay? But it is much better that if you're going to acquire all the data here or the result and then use another program like Excel or spreadsheet to do the design. Kasi kung titignan mo, you cannot have a proper design here. So the implication of this one, we do not have any result here, is that your member should be resized to be enlarged to accommodate the loading. Okay, so that's done. So with this is just an initial analysis. So you should analyze it again by adjusting your member dimensions, okay, to cope up with the loading. So we close that for a while, and then I just want to point out that on the STAAD output, we always encounter this type of error if this UBC or IBC analysis. So normal lang yan. So just normal to encounter this. But if you want to remove that one, you can do it by STAAD editor here. Just tick that one, and then we go to this one, seismic load, then UBC. So we just edit, lagyan ko lang ng perform analysis and then change. Okay, dun tayo sa sa seismic. So hanapin mo yung seismic load 1 and load 2, yung may UBC load Z and UBC load X. So just type perform analysis and then another line, change. Okay, so we just close this for a while. So tatanungin, save changes. Of course, we tick yes. And then we reanalyze. So kung makikita nyo, zero warning na. Okay, so view output file. Okay, so wala na, natanggal na yung UBC warning kanina. Okay, so that is analysis of frames that uses ranges or define range scheme in order to model your floor load. Okay, so magkaiba siya dun sa grouping or the tool group that we have utilized before. Okay, so at this point we will have footing design. Okay, so what you do is from your existing file with the seismic analysis, i-save as mo muna siya. So save as to preserve your work framing. Ito, no, footing. So lagyan mo lang ng footing, no. So, para ma-preserve mo yung dating analysis mo. Okay. So, this is another type of file. Ang gagawin lang naman kasi dito is you go directly to the loading. Tapos, tanggalin mo lang yung mga seismic definition. So, anything that relates to seismic or earthquake, tanggalin mo. So, we delete that one. As well as EQX and EQZ. At yung load combination na dalawa, which includes EQX and EQZ. No? We press delete. Okay? And then, sa design, of course, hindi na concrete design to. So, from the design tab, tick that one, and then tick concrete or reinforced concrete. So, magiging active yung itong folder na to. So, we select that one, then delete. And, yes. Click yes. Okay, from that, tanggal na yung earthquake as well as the RC design. So this time we're going to have this footing design naman tayo dito, and then punta ka muna dun sa model and then select all of the footing nodes, okay, by the footing cursor or the node cursor. Select mo lahat yan. So na-select na, and then we define parameters. So, footing tayo. Define parameters. So, the bearing capacity shall be specified. Halimbawa, may bearing capacity tayo ng 135 kilopascal. So, we simply assign that one. And then, FC prime, say 20.7 or 20,700. So, assign. So, Fy or the yield strength of steel, say 276,000, then assign, then track, numerical output sketch provided, say we select track 2, then assign, then close, then commands, then assign, close. That's it. We are now ready to run analysis, and then we just save it. So there's problem. So I think we should fix this footing design. Say we remove this code. Analyze again. We have the same error. Okay, so we have settled that one, So before, dun sa ating editor kanina, we have ayun, nilagyan natin ng perform analysis and change, di ba? So kanina, so we analyze that one, then run analysis. We do not have any error. So ang ginawa ko is I have deleted, kasi nga you have deleted the earthquake loadings as well as seismic definition. Naiwan kanina dito yung ating perform analysis and then change, yung nilagay natin kanina. So I have just deleted those ones and then reanalyze We analyze it. We have now our output. So if we view the output file, you can see here the sketches of your footing design. So footing design will be referred from the plan or the nodes. Now, for example, footing at support 2. Halimbawa, ito footing at support 1. So where are you gonna find those ones? Dito sa baba. Then view, selected objects only. So we isolate those nodes, and then we just press Shift N para makita nyo, Shift N to turn on the nodes. Shift N. So Shift N, Shift N. So nasaan yung footing 1 dyan? So yung footing 1 is this one. This is the footing 1. Okay. Footing 2, 3, 4. So everything or every footing was labeled. And then if you want to put it off, Shift N again, mawala lang. So of course you need to have the label para makita mo kung nasaan yung mga footing na to. So again, you can fix your design kasi iba-iba yung binibigay dito. You can have the most conservative for internal columns, for example, or the most conservative for external column and internal column, and have two types of design. Hindi yung napakaraming design. So at least you have here initial design of your footing. Okay, so the dimensions are given, the reinforcement, as well as the required thickness. Okay, so I think that's it for today, and let us have more practice. Thank you for listening.